going fine. Okay, I'm gonna start trying. Were you interested in the quantitative analytics lab project?
Yeah, but I wasn't totally sure everything about the project.
Okay.
'Cause I know there were some messages last year, but basically I was a little bit too swamped with or last quarter, sorry. But I was a little bit too swamped with my current research that I just didn't really have time to take on any new projects. So
I see. That makes sense.
I made up, a lot more room, and I definitely love to use my machine learning experience to shift to more quantitative analytics side.
Mm-hmm.
Yeah.
Okay. Um, okay. So let's just go over what it is. So this project is through the quantitative analytics lab, and we're gonna do a project based on mean reversion. Okay, so what is QAL? It's basically an organization that partners with companies in the industry to like create projects so students can get hands-on experience. And I represent Quant Connect, which is the algo trading platform we use. And here are some reasons why we should use Quant Connect. It's all free, so hi. We just started, so you don't really miss much. Yeah, this is the previous slide.
Oh, thank you.
Okay. Here's some more stuff. And for anyone who's watching the video, I'm gonna post the slides, and at least hope to remember. I'll try to post the slides in the chat. Make it so that, okay. So basically, what this project is that we're going to implement this paper here. Let's just look at this paper. So okay, so so what the paper is it basically regresses BTC against 3 other cryptos, and then it buys longs BTCs and shorts the 3 cryptos based on the regression residuals. If it's like below a certain level, and it goes short on BTC and longs the other 3 cryptos if the regression residuals are at a certain level. And so what are the required knowledge you need for this project? The first thing is you need a stationarity, you need a ordinary least squares regression, basics of crypto trading. Like, it's not like anything special. You don't need to know how crypto works. You don't need to know how like hash all the fancy crypto stuff works. So wallets. No, you don't really need to know all that. But you do need to know how crypto is traded. I also want to know some basics of Quant Connect. Okay, so the first thing I want to go over is what stationarity is. Stationary series is basically a series that has like constant mean, which is the average, and variance over time. And variance is like how much it varies. So this is relatively stationary. It's not like a perfect stationary series, but it is quite stationary. This is an example of a non-stationary series. Does anyone know why this is not stationary? Okay, let me repeat it. So it's constant mean and variance. So stationary series has constant mean and variance. What happens with this series?
The mean and the variance are increasing as time goes on.
Yep, that's correct. Okay. Now ordinary least square, just think of it as like a line of best fit. And so what you do is you take all the points and you take the distance, the vertical distance, you square it, and you take all these vertical distances and you want to minimize the sum of these square distances, and so you get this line. And so why do we use square distance instead of absolute distance? Well, you can use the absolute distance. You don't have to square it, but the square distance has a lot of nice properties. Both in the statistical sense, in solving systems of equations, and from a linear algebra perspective. There's like a bunch of reasons why squaring is nice. It just makes solving for the best fit easier. Okay, so just think of it as a line of best fit, and these are the residuals. You see this distance. This is residual. Okay, let's keep going. Crypto is basically a secure digital currency. And you trade it in pairs. Similarly, you do with Forex. So instead of like your USD, you do like BTC USD, or you can trade two cryptos, Bitcoin and Ethereum, through BTC ETH or something like that. I'm not sure if it's ETH BTC or BTC ETH. I can't remember. But and even though it is a decentralized currency, you can still trade it on the exchanges like Binance, Bitfinex, etc. Okay. And to learn Quant Connect, you can watch this. There's some like Quant Connect videos in this playlist. There's the Algorithmic Trading Club channel, or you can even email me if you like need help with a code or something. Okay, that's it. Now I want to go over some stuff that you need to know in Quant Connect. Okay, so oops. So this is a research notebook. If you guys want to, you guys can just create like a free Quant Connect account right now. You don't have to. It's the sign up is not very hard. You can just sign in with your Google account, and it's all free. The only thing that's not really free is that you might want is live trading, but like backtesting and data and almost everything's free. Okay. Okay. So what I did was so you could just create like you. Okay, let me show you guys how to. Okay, so let me show you guys how to like create admin. So go sign in. You sign in with your Google account. I'm gonna sign in with. Go on. And then there's like these different tabs. It automatically opens up to my projects. But if you're like on the home tab or something, you just go to the lab. I don't know, it's called lab. I feel like it could also be called projects. It's whatever. Then you go to here, create new algorithm. I already created an algorithm. If you already made a new algorithm, it's usually down here. Then you add a new notebook. And you type in the notebook name, and then you open it, and you run it. Okay. So what does this do? So QuantBook is a Quant Connect object, a Quant Connect class object that allows us to access data and stuff like that. And so we want SPY data, so we add SPY data. We want QQQ data, so we add QQQ. Okay, so what is SPY? SPY is the SP500, and the SP500. Well, it tracks the SP500. And SP500 tracks the 500 largest companies by market cap in the US stock exchanges. QQQ is 100 biggest stocks on the NASDAQ exchange, okay? And now we want to get the data frame. So QB.history, we want historical data, so we call history. QB.securities, and so these are securities, SPY and QQ are securities. And then we access that .keys to get the symbols. And so these are the symbols we want data for. Then we do 100 days and then daily resolution data. And you can see it looks like here. It's accessed on two indices. The first index is for the symbol. The second index is for the height. And so what happens if we want just the SPY data frame? We want this stuff, but we don't want this stuff. We can just do .loc the way you do. Oh yeah, this is a pandas data frame, okay? This is a pandas data frame. Okay, so you do .loc. It's basically how you do indexing in pandas. Okay, and then so we get the SPY data frame, and then we want to access the closed column, and to access columns in. So this is indices. These two things here are indices, and you can tell because the words are slightly lowered, and these are the column names. Okay. And to access a column, you just index it by the column directly. You don't need the .loc or something or anything. So we got the data frame, and then we access the closed column. And we do this for SPY and QQQ. And you can see that this is just basically a time series of the prices of SPY. And this would be the time series of the prices of QQQ, okay? And now let's plot against each other. So we just create a scatter plot of SPY QQQ on the x-axis and the SPY on the y-axis, okay? like there's nothing special. And now we do linear regression. So this is one way to do it is use stats model. There's like different libraries. You can also use sklearn. There might be other libraries, packages, but most stats stuff can be done with like sklearn, stats models. Arc is a library called Arc, and one of them is deep learning packages like PyTorch, Keras, etc. Okay. Okay. So why do we add a constant? So this add constant. Okay. So the form of a linear equation is y equals mx plus b. Okay. Well, like the typical form. So this b is a constant. Okay. But if right now, because of reasons, it's gonna be like this. It's just gonna be y equals mx because we don't have a constant. We don't have an intercept. And so when we do add constant, what it does is it just pens. Let's just and so you can just see it adds a constant. It just adds a 1. There's a linear algebra reason for this. It's a little confusing. It's a little confusing if you haven't taken like linear algebra and machine learning or somewhat like a class like that. But so if you've taken 318 or if you've taken math 318 or if you've taken CSE 446 or you're currently taking it, then it would make sense why you would add a constant. But I'm gonna go over it later. Let's just skip it for now. Okay, so let's have earlier we put a QQQ on the x-axis, so let's just have x equal to the QQQ and y equals pi, and we do ls. It's y in front of x. Don't ask me why. It's just how it is. It's how they coded. Okay, and so then we do fit. It's kind of weird. What? So this you just fit it. Okay, it looks kind of weird, but it's just how it is. Okay. And the results contains a lot of information like the parameters, the residuals, etc. And so you can see here const, that's the constant, aka the intercept. This is the close. This is the slope. Okay. Okay, now we can also get the residuals. And let's go to the slides. Oh, shoot, I'll close my slides. So you see these black lines, these are the residuals. And so we just plot the residuals over time. Okay. And let's create the line of best fit. Okay. So now we create a linspace 300 to 50. What that does is it creates 100 points, equally spaced points between 300 and 350. Okay. And then we plot this on the x-axis, and then we plot the y equation for the y-axis, which is slope. No, that's the intercept. Intercept, or the constant, aka the constant, plus x times the slope. Okay, and that's what you get. Hopefully that will make sense. Does any part of that not make sense? It might not make sense if you don't have a basic understanding of statistics or anything. Okay, hopefully that all makes sense. Now I'm going to go over how to get data into a data frame. So let's first create a rolling window. So self.rw equals rolling window. Then we use this to specify the type, and then the argument we use to specify the duration. Let's just do 20 for now. And so what is a rolling window? It's basically a backward Python deck, but it's like C#-ish. It's like a C# object, okay? Let's see what it's like. Let's just create a new. So RW equals rolling window.
So are there any API differences between these, like, quantum like histogram objects and pandas data frames?
What?
Are Are there any differences in like the API usage with just a normal pandas data frame? Or is it just pretty much vanilla pandas for all of this?
Sorry, you're a little quiet. Can you like repeat the you can type it out.
So
that's better.
Does the API reflect the same like pandas API, or are there any differences with these specific QuantConnect objects? Or is it literally just making like is it literally just making a pandas data frame?
I'm not really sure you're asking, but here maybe let's do some coding, and if your question like if your question comes up again, then I can answer.
Okay.
Let me just say this. Okay, pandas in QuantConnect is just pandas. Like I imported pandas as PD. Well, no, actually I didn't. But pandas just.
I guess I'm wondering about these like QuantBook objects at the top.
Yeah. What are these? Okay, so the QuantBook object is a QC algorithm, QuantConnect object thingy that we have access to because QuantConnect provided it to us. That allows us to get data for various securities.
Okay.
And this data is in a pandas data frame format. Let's just do type hist.
You said qb.history, it's gonna return it in data frame. Okay, cool. That makes sense.
It is literally just pandas data frame. It's nothing special.
Okay.
And this rolling, okay, 10. Okay, no, let's do 5. No, pick 3. Okay, rolling window dot add 1. 10. Okay, so it's basically backwards deck. So it's basically deck, but like for some reason, the lower the index, the more recent it was added. Like usually in queues, if you're familiar with, if for those familiar with queues and like from a computer science perspective, queues usually actually it doesn't really matter. It doesn't make sense. It's basically a queue, but like the most recently added stuff is at the beginning, which is kind of weird. And so and you can see that the last index is the first element added. And now let's roll that add. Let's add like 1,000, 10,000. And let's print roll window. And you can see that the 1 was pushed out. And the 10,000, the 1 was pushed out, and then the 10 is now the last element. Now the first element is the 10,000. Okay, hopefully that makes sense. If self dot if data dot bars. And when you're using rolling windows, this is what I usually do. I just cast it to list. You can just do list. Like I think there's some internal function for the rolling window that allows us to turn it into Python list or something. Then I invert it to get everything in temporal order based on time. Okay. So that's what I usually just do before I ever want to use a rolling window. Oh, this actually has to be a slice object. So if self.data.bars.contains key is by, and the reason we usually do this is because onData can be called for a lot of stuff. Like this data is a slice object. Okay, this data is a slice object, and let's look at slice objects. Slice object. Slice class members, delistings, my bad. Delisting. So it can include delisting information. It can include dividend information, and while it can it can come during the aftermarket hours. So the bars, which is where the candlesticks are stored, like basic. They're similar to candlesticks. They have open and high, low, close volume information. So these bars might just be empty or just be null when passed in when a delisting happens, okay? And so we want to make sure that we actually have data before adding the slice to our rolling window. And that is because of the rolling the add data. Okay. And because like we sort of get some weird error, like because some of the slices don't have bar data, it just has delisting or dividend data, and so it might screw stuff up. Okay, hopefully that makes sense. If something doesn't make sense at any time, feel free to like make sure to stop me and ask me. Okay, actually let's do this. Not return early. Okay. Okay. How do we tell if the rolling window is full? Let's go back to our notebook. So we add one element, and the rolling has capacity 3. Rolling dot is ready. Okay, so and you can see that the rolling window isn't ready until there's 3 elements in here. Okay, so it's basically full. So if self.rolling window is ready, then what we can do is not, and then return. What we can do is I'm gonna pick this and turn it into a data frame. Okay, so df equals and then let's just see this.
Got a question.
Yep.
Can we do all these backtests in the notebook?
Nope. That's a good question. Notebook is usually you just want to pull data and analyze the data. Here you can actually run an algorithm.
I see.
Okay, so like we just have access to data here. That's the main reason. Here we can actually just run it. And when we want to go live eventually, which is like our end goal, maybe, we want to go live. And then
Okay.
we have to run it from here. Oh, so let me just get this clear what the distinction is.
So can we like create a Python 5 that contain all, like create another Python 5 that we put all the logic in there, so we can like import from both main and notebook?
Like let's take this. No? Okay, let's go over that question. So can we create a new Python file? Yes, we can create a new Python file. Let's do 5. And def from 5 import 5. Okay, so 5 f. Yes, we can import stuff. We can create a new file and import stuff from it. Okay.
Okay.
And then we can import it. We'd have to. Sometimes it's buggy. It's sometimes bugged with the notebook. Let's see if it'll work. From 5 import 5. So you have to create a new notebook. Okay, let's try creating a notebook. Like you have to create a new notebook because the old one doesn't register for some reason. Is my notebook. Stop it. So you have to create. Okay. Does that answer your question?
I think I get the point. Yeah.
Okay. Good. God, it's so slow. Heck. God. It can be a little slow at times. Let me just, what the heck? Just do that. It's gonna, what the heck? Okay. There we go. Thank goodness. Okay, please. Can I see it? Why is there? Okay, so that's how you can get into data frame format. And so why is this useful? It's when you have like 4 things, when you have data for like Bitcoin, BCH, Bitcoin Cash, Ethereum, Litecoin. I can't remember the exact ones that was used in paper. You can just get the data from here, create the data frame, and get the closing prices for each of these securities. Okay. Here, let me just go over something. For stationarity, use the ADF tab. Python. I think it's this thing. It says it also they also use the Johansson test in the paper, but there's no good Python implementation. I don't think. Pretty sure it's broken. Or it's not very good. Just use the ADF and the Phillips Pearson. Phillips-Perron. I can't remember. I think it's Phillips-Perron. Yep, this one. Use like these two to check for the stationarity of the residuals. Okay. Does anyone have any questions? Like, does okay, look. Okay, let's go back to this. Let me explain more about how the paper will work. Okay, so this is QQQ on the x-axis, QQQ. This is SPI on the y-axis, and so we fitted the regression line. And so we can see that there's a residuals over time. Okay. So what happens is when it goes down here, that means the price of QQQ is falling relative to SPI. It's like falling below the slope, okay? And here it's going above the slope. And so what you will basically want to do is you want to, so up here, it's sort of like SPI's overpriced and QQQ's underpriced. What you want to do is short SPI and go long QQQ. If it's down here, you go long QQQ. No, you short QQQ. Wait, no, just kidding. Wait, that's actually wrong. No, this is a residual. Oh, sorry. Oops. This is time. This is T. This time. This is a residual. Oops. Because we had QQQ on the x-axis, anything below the regression line is like down here, okay? And anything above the regression line is like above. So this is like below 0. This is above 0, okay? This area. And so when we go below the regression line, we're like down here, right? And that basically means I think, I'm not sure. Can't wait. I think it's that the QQQs over there. No, yeah. Sure, I can't remember. I don't know. It's explain the paper. So yeah, so you want to like short one and then long one on the other one, and then you want to flip the position up here. Okay, hopefully that makes sense. Okay, so does everyone have this paper? Can you guys like?
Is this the same one as the one you gave last quarter?
Yep. Well, like for anyone.
What's
Yep.
the
Okay.
Oh yeah, and did you try to do it?
Did I?
Yeah.
I already did it.
So what I did, like, given the recent information, like if I backtest from around 2019 to 2020, I can replicate the result.
Did you have it?
Yeah.
Oh yeah, I saw your work. You don't have it. Yeah, I think what you have right now is pretty good. I think you should like put this code in Quant Connect or something. so that you can actually
Oh,
test how it does.
Oh, okay, but like, but even from this graph, I think like given the recent boom of crypto, it doesn't really like reverse anymore. Like, did you result reversing back to the mean?
What?
Like, did the result that you make reversing back to the mean?
Does it reverse back to the mean?
Yeah, from my graph, like it's really hard to going back to the mean, because like from like this is what I understand is that like Bitcoin is so like it's goes so much such that like the variance is so large.
I don't know. I'm not really sure. Well, like you long. Well, the thing is, like you go long on BTC and you short the other three cryptos. So if Bitcoin goes, so that if all of them go up, you like have long positions and you long short positions, and if they all go down, you have long positions, short positions, like relatively neutral. You don't go long on all of them. You just like long some and you short some. Yeah, I can. This is how it does. It doesn't really trade a lot.
Oh,
cool. Yeah, I can rerun it. Well, don't copy this. Like this is the implement. This is done implementation. Okay. I'm gonna run it again and see how it does. Like, well, you can't copy it if you want, but it defeats the purpose. So you can look at this. So I Phillips Perron and AD followers test for stationarity. And when you test it, you get a statistical significance. You just want to like make sure that the like you could check like for 5% significance, 10% or 1%. It's not okay. Well, it's not running. It's too slow. So, how do you say your name? Varik.
Varish. Yeah,
Varish.
that's good.
Varish. Okay. So can you try like putting in Quant Connect? If you need help, you can just like tell me.
Oh yeah, sure.
And maybe so, like try. Well, like don't implement it. Well, you can't implement exactly, but like also like experiment with like other baskets. Like maybe like if you do JP Morgan, you do Wells Fargo, you do like I don't know. Or you can do Forex. You can do like Forex stuff. Just try some. Well, it's up to you. You don't have to, but okay. It seems like you got most of the work done though. So that looks good.
Yeah. So like I look at the graph and it spiked so much. I just like screw it. I didn't even backtest it.
It doesn't matter. You just need back. It doesn't matter if it does good or not. That's not really the point of this. The point of it is just sort of like implementing a paper and like getting hands-on experience. Okay. So like I have a bunch of algorithms that don't do well, but it doesn't matter. I implement it anyways. Let's see some of these. This one's horrible. Some of these just lose money. Like it looks. Let me see one that is really bad. Well, none of them are that bad, but compounding annual gross return of 0.5%. That's like nothing. This is pretty terrible. The basic like doesn't make money. Okay, but I just implement.
Projects that like how they define like research question.
What?
Are there any projects with the quantitative analytics lab that kind of have like an open research question to them?
Open research questions?
I mean,
this project is to get. It's like a test, sort of like.
Okay, that makes sense.
We're gonna have more projects for people who complete this project. Okay. This is not too hard. Like I mean, it's hard, but it's like it's doable. Like some stuff that's like crazy. Let me show you guys something crazy. It's already on here. I mean, this was pretty crazy. Okay. Yeah, like some people say, okay, so the thing is, like, some people say they want to do research, right? But then they don't do anything. So we just need to filter out people who can actually do something. Okay. So if you can do this, then we'll consider you for future projects. Does that make sense?
Yeah, that makes sense.
I mean, you don't have to, like, if you have struggles, like, you can always ask for help. It's like, even if you can't do it, just ask for help and then you can do it. But like some people, they don't know how to do it and then they just don't do it, or they just don't do it in the first place, right? Okay, is there any more questions? Okay, that's gonna be it for today. Okay, so for next week, I want you guys to, well, like, if you haven't already, I want you to like skim the paper and maybe like write down some stuff that might not make sense. Here, let me put this in the slides. So for next week, and okay, that's what I want you guys to get done for next week. Any last minute questions before I end the meeting? Nope. Okay. See you guys. What?
Okay.
Thanks.
If I saw you did something with Wavelet, is it help?
What? Rev what?
I saw you did something with Wavelet.
Wavelets? Oh
Yeah.
It was not very good.
Oh, okay. I just curious, like whether it helped or not. Yeah.
Like most of the things, like most ideas won't work, and a lot of the papers are horrible.
Okay.
Like, okay, so the thing is, like, if they actually have a good strategy, they probably won't publish it, right?
Yeah.
They want to share it with people, and if it does, and usually people like backtest it on like 2 months of data, and it just so happens to do good, or they don't account for feeds, spreads, etc.
I see.
Or they just like tell you how to implement it. They don't even give you results. I think some of the papers, like, they tell you what the model was, but they don't actually give you the results, and they're just terrible. Okay.
Oh, so you do it.
But yeah. Well, like, the more you implement, the higher probability that you might find one that's good. Okay, I'm gonna end the meeting. See ya.
Okay. Bye. Thank you.